presenting problem number 10, elastic bones. This is the problem statement, which I will not go through, and I wanted to look at the relevant bone components for this problem, and also look what the acid changes in the chemical structure of a bone, and also look at an explanation for the phenomenon. So first, what is the phenomenon? So we have a bone, and we put it into an acidic liquid, and then we wait a while, and when we take the bone out, the bone should have turned elastic. If we look at this at the mechanical properties of a bone, we see that the bone is rigid, so it can deal with all kinds of forces, even with twisting, so we can walk, for example. The bone also has to be a bit elastic, so we have a reversible deformation, so we wouldn't fracture our bones every time we walk or try to do any kind of movement. And of course, because it is elastic, it would then return to its original shape. These properties depend on the type of bone, so long, short, flat, or irregular, and the size of bone, so larger, smaller, and thicker or thinner. So if we look at measuring elasticity, we have a bone, and if we hold it on one side and apply a force, the bone should deform. The bone has to deform enough so that we can have a quantitative measure of how much this bone deforms. So if there is a microscopic change, I cannot measure it as elasticity. So when the bone returns to its original shape, the bone is elastic. If we look at the bone components, we have 60% mineral, 20% protein, and 20% water. Now we have to consider that we have a chicken bone, which means that they are whole inside, so they don't have as much mineral and protein and water as in our bones. So this is what the inside of the bone would look like about. So we have our protein in the collagen fibrils for elasticity, and then we have minerals for rigidity. So if we look at the collagen fibrils more exactly, we can see that they are a protein, as mentioned. They are also long, thin fibrils and insoluble in water. They are very stable in acidic conditions, and they are stable until the pH of 1 or less and up to 40 degrees Celsius. If we look at the mineral is called hydroxyapatite, which is a salt. It is also insoluble in water, and this would be the chemical name. Here we have the chemical structure. We have calcium ions, phosphate ions, and hydroxide ions. So if we look at the chemical reaction, if we have our water and we add our acid, then we have an acidic liquid. We want to get rid of hydrogen atoms, and so if we put the bone mineral inside, the bone mineral will have a chemical reaction which would dissolve the hydroxyapatite. So if we look at this chemical reaction like this, we have our hydroxyapatite in any acid, which would be, in my case, I took 8 hydrogen atoms, and so that would give us calcium ions, and we have hydrogen phosphate, which is what is also possible is that we have dihydrogen phosphate and trihydrogen phosphate, and we also have water. And then if we look at the elasticity again, we can see that we have our bone mineral, and we have the collagen fibrils, and if we put the bone into an acidic liquid, then the bone mineral will eventually dissolve, and the proteins will remain, which means that the bone will become less rigid and more elastic. Now, if we look at the bone mineral again, we can see that we have this hydroxide ion. There's also something called fluorapatite, which we can change with fluoridation, so we would just have this fluoride ion, which would look something like this. This is a way stronger ionic bond. So if we look at the hypotheses, for my first hypothesis, for the fluoridation of bone, I believe if we fluoridate a bone, it will become elastic slower because of the chemical reaction. It is a stronger bond, so the acid would have a harder time dissolving the mineral. And for the size of the bone, I believe a smaller bone will become elastic faster than a larger bone than a thicker bone, because I believe that there is more mineral to dissolve in a thicker bone. Now, if we look at my experiments for the parameters, I looked at different acids, I looked at different types of long bones, and I fluoridated some of the bones, and the total durations of the experiments were 4 hours to 1 month, depending on which experiment it was. Then, for the measured variables, I measured the pH of the liquid, and I measured the bone length, weight, and elasticity. For my control experiments, all the chickens I used were 10 weeks old. I took the long bones at 50 minutes, 200 degrees Celsius, and I used wing and leg bones. Then I always used 800 milliliters of liquid, and then I had a constant temperature. So I did a total of 12 experiments with 36 bones. Then for my materials, this is a show of my materials. I will go through the most important ones, which would be fluoride, and then we have pH measuring strips, we have vinegar, formic acid, hydrochloride, we have water, And of course, we also have the chicken bones, and then we also have a force meter. So my procedure was that first I prepared the bones, which means I would clean them of all the rest meat that they would have on them, and then I would fluoridate the bones that I had to fluoridate and let them set so there could be a chemical reaction that happens instead of just fluoridating them and then putting them directly in the acid. So I put them in the liquid, either acidic liquid or water for control. Then I measured, the measurement intervals were 30 minutes to 1 day. And so I removed and measured again the pH of the liquid and the bone length, weight, and elasticity. So my setup, here you can see my sand with a bone and a force meter, and you can see 3 types of bones in 3 different acidic liquids. So how did I measure elasticity? So if we look at this picture, I always pulled with 10 newtons of force, which here you cannot see any deflection, but in this case this bone is clearly elastic, so it has a deformation that we can see. So the elasticity measurement is equal to the bending angle alpha. So we have the sine alpha, which is equal to the bending over the bone length, which is equal to 4.5 centimeters over 5.5 centimeters in this case, and that would be about 0.81. So this is alpha here, and then we have alpha equals arc sine 4.5 over 5.5, which is about 55 degrees in this case, which means elasticity that I measured in this bone case would be 55 degrees. And then if we look at the chemical reaction, here we can clearly see gas bubbles, which indicate that there could be a chemical reaction happening, though they could just be natural bone bubbles, they could just be natural bubbles from the liquid. Then here we can see a chemical reaction. We can see that, for example, these 2 bones have a complete different color. And we can also see that there is calcium acetate on the bones, which you can see here, there is white stuff on the bone, which is the calcium acetate. Then, if we look at my elasticity in different sizes of bones, for my horizontal axis, I have the duration of bone in liquid in minutes, and I have in the vertical axis, I have the elasticity and bending angle in degrees, and this my measurement weight only goes up to 90 degrees. And if you see, this is hydrochloric acid, for example, and so you see they reach maximum elasticity in 4 hours, and the different sizes of the bone. So the thicker the bone, the longer it takes to dissolve. And I saw the same patterns in different acidic liquids. With the fluoridated bone, I saw again 4 hours, and so the fluoridated bone became elastic slower, and the same pattern in different acidic liquids. Then for the conclusion, so I saw, as the problem states, that the bone minerals did, that the acid did dissolve the bone mineral. I also saw that the fluoridated bone was strengthened, which means it became elastic slower, and the thicker bone became elastic slower than the thinner bone. Here are my references. Thank you for your attention.
To prove that it was the mineral that you had predicted that leached out?
So, by changing the chemical reaction with the fluoride, it shows that there is a chemical reaction with the mineral because it took longer with the fluoride.
But what was the mineral that you were saying was leached out of the bone?
Well, of course it is made of multiple minerals, but this is the most common one, and this is the one that would have the strongest reaction. It would be hydroxyapatite.
So did you prove that that was what remained in your beaker after your experiment?
I'm not sure I could have tested that since it had chemical reactions with the acid, which means that it would be...
Thank you. Did you measure the pH throughout your experiment, or did you measure the pH when you first started the experiment?
I measured them every day or every 30 minutes, depending on which experiment.
Did you change the acid throughout your experiment?
I had different experiments with different acids.
No, but during one experiment, was the acid changed throughout the same experiment?
No, one bone was always kept in the same acid.
Okay, thank you. So, what temperature were these all kept at, and were they all constant?
They were all kept at room temperature, which in my case in Switzerland would be 18 to 20 degrees Celsius.
You said that you measured elasticity by the degree angle that it was able to bend, but then you defined elasticity as the ability to go back almost instantaneously to its own shape. How did you measure this in your definition of elasticity?
Well, of course there was some error, as I showed in my graphs. There was some error, and also, of course, I looked at the bone looked as similar after I measured the elasticity. So I would say that the bone did return to its original shape after I measured the elasticity.
Thank you. What method did you use to test your pH?
I used pH measuring strips.
Okay, thank you. Did you change the concentration of your acids anytime during your experiments?
Well, I just used different types of vinegar, which already had a concentration, and with the hydrochloric acid, I used 8%, and with the formic acid, the same.
You only used the 2 types of acid then?
No, I used 6 different types of acids.
Were they all at the same concentration?
No.
Did you compare their pHs? Is that how you measured it?
Yes.
Okay. Thank you. So, does your experiment account for the fact that you weren't, they didn't have all the same concentrations?
Well, yes, it does.
Could you give a short answer as to how?
Well, I would take, of course, we can't change with the hydrochloric acid and formic acid, I didn't want them to have a high percentage because that would be dangerous to experiment with.
Did you measure at all, for your definition of velocity, how it bent back?
Quick answer, please.
Yes or no?
Yes.
Okay, thank you for your questions. Now we have your preparation.
For problem number 10, elastic bone. So this question, as we've already seen, I believe was asked so that the chicken bones kept in its acidic conditions would become elastic, which was important. And something else to investigate was what components of bones and how they were responsible for their mechanical properties. So, addressing the problem, we believe that the practical work was average, and the mechanical properties investigated, the components of bones investigated was average. However, we believe that the theory was good. This was because we didn't feel that, some of the strengths we feel were that the theory was good because there was a good definition of elastic. We believe that this definition of the ability to go back to its original state is an important definition of elastic, and this should have been taken on more so in their theory. Another strength they had was that they defined the components of bone correctly, and the theory was very good. So in their practical, some of the strengths were that they used different acids and they used different bones, and that they managed to measure their pH throughout. The strength of this is that the different acids they could use were comparative, so they could compare how different acids affect the bones. Using different bones also said that because the question asked us to address how different bones were affected by these acids, so this was a strength. And by measuring pH, they were able to make sure that the H+ ions they were able to measure how the H+ ions in the acids were depleted throughout their experiment. However, some weaknesses we found. So, firstly in their theory, although their theory itself was quite good, there was not much of a link to how they proved each part of their theory and everything they predicted in their theory through their experiments. This was because their method led to a bit of inaccuracy. So, first thing that was weakness in their method was that they did not change the acid. The reason that this is a problem is because as we mentioned before, the H+ ions in the acid could have been depleted, and also something that happens when the bones are reacting with acid is as the calcium leaches out of the bones, this can create a buffering effect that leads to a region of inefficiency of the acid, leading to the bones not being affected as much as the original state it would have been when it was originally put into the acid. First, and then they did not have the same concentration for their acids, which could have led to some inaccuracies in their method. And finally, they couldn't prove what mineral had leached out. They said that there was no easy way for them to do this. However, we believe, as they had said, that there was calcium leaching out, and they knew a mineral that had been leaching out, and they were hypothesizing this. They could have done this by a simple precipitation test or even a flame test, which would have proved the existence of what elements had leached out of the bones and were in the acid itself. This was what we believed was the biggest flaw of their experiment. Some points of discussion was elasticity. How was this measured? I mentioned this in my clarifying questions. However, they did measure the elasticity as the degree angle that it bent. However, we didn't find that their definition of elasticity, which they had mentioned in their theory, was exactly proven by how they did their experiment. They defined their elasticity as the angle of how it was bent. However, they didn't show in their experiments how it was bent back. They said that they did mention that they did do an experiment which proved that these bones were elastic as they did bend back. However, this wasn't very clear in the report, so it wasn't put for discussion. Another thing was the method, and as I've already said, the changing of the acid and the repeat. The changing of the acid was important because this can cause things such as the H+ ions being depleted and a buffer becoming more and more around the bone. Another thing we wasn't mentioned is how they repeated their experiments. We believe that as they repeated their experiments and added weight to the bone, this could have itself changed the mechanical properties of the bone throughout their experiments, but we believe this was not discussed. Also, finally, they said that the pH of their acid was the only thing they had measured and not the concentration. We'd like to discuss whether the concentration could have had an effect on the bones and their mechanical properties as they are affected by the acid. And finally, we want to readdress what was the reason for the bones changing in the acid and redefine what the mechanical properties were that were changed by the acid and the bone being placed in it.
Okay,
Without further ado, I'd like to invite the...
Thank you. Let's thank first of all the opponent for their position. The discussion is in force.
So firstly, I'd like to ask you how exactly elasticity was measured. You said that there was an experiment that you conducted that returned the elasticity, that showed that it was in fact elastic, meaning that it could be reverted to its original condition. However, in your experiments, in practical work, we only saw that your experiment showed that the angle of bend was elasticity. How do you define elasticity and how do you link it to your practicals?
Well, of course, they did bend back, because otherwise I would not count them as elastic if they just stayed in the position that we measured the angle. I did not show a picture because I believe that with my explanation of the elasticity, I would have thought it unnecessary to also show a picture of it bending back.
Okay, but if you showed that all your bones may have bent differently or the angles may have changed differently, did their rate of going back to their original state differ between the bones?
I'm not sure I investigated the time amount, but I believe all of them had about the same time range.
So, about the same time range. Okay, thank you. Also, addressing your method, you said that you didn't change the acid throughout the experiment. However, when bones are put into acid and calcium reaches out of bones, it can create a buffer around the bone which reduces the effect of the acid. Do you believe that this could have led to any inaccuracies in your data and how your practical was taken out?
Of course it could, and also, I'm not sure if I understand you correctly. Do you mean changing the acid during the experiments when the bones are in the acid?
Yes, changing the acid to renew the acid with the same bone.
Well, yeah, I didn't do that because I believe that acidic conditions are commented as we leave the bone in one acid, so one acid can change.
Thank you. So also something that can happen in the acid is that the pH can change. You said that you did test the pH, however, did you link this to how the H+ ions should have been depleted in your solution and then change the acid? Because we believe that if you check the pH and notice that the acid was being depleted of H+ ions, you should have actually changed the acid to make sure that the initial conditions were stayed throughout your experiment.
Well, the pH did change in some of the acids by 1, so for example, pH 3 went to pH,
Okay, then does that mean that your initial conditions were different?
You can see that in the cleaning vinegar, clearly the pH went up, white wine vinegar, and also the table vinegar. But for example, in the lemon juice, and also the hydrochloric acid and formic acid, the pH did not change.
But the ones that your pH did change, then the acid was different to how you started it and how you ended it. So then some of your acids did not change the pH, and however, some of them did change the pH. So some had constant initial conditions and some did not. Is this correct?
Well, yes, but I don't think that it does, of course, have an effect that the reaction is a bit slower, but the point is, if the pH changes, that also shows that some chemical reaction is happening.
Okay, thank you. So in your method, the next part I found was that when you repeated it and added a force to the bones which were elastic, could this actually have changed some of the chemical properties by just adding force to it over and over again?
It could have done a slight effect, but because I tested it the same way with every single bone, I don't think it has a great effect on my results.
Are you saying that adding a force to an elastic object and then removing that force and doing this experiment over and over again could not have changed the elastic properties of the mechanical properties of the elastic bone?
It could change it a little bit, but I don't have another method that we could test this with. Do you have a suggestion?
A suggestion would have been to account for this in your error. So instead of saying that by doing this experiment not accounting for it, even if you couldn't find a proper way to say that it could have changed a little bit, this little bit of change should have accounted for in your error.
Well, of course it was also counted in my errors.
Oh, okay, then thank you. So you said that you only measured the pH of the acid, and this was what you had changed. You used different acids at different pH. However, all these concentrations were different. Do you believe that this could have affected your experiment?
Well, I did try a different a different concentration with the hydrochloric acid, and I did not see a different effect. With the vinegars, I could
So
have
you only tried a different concentration with your hydrochloric acids.
and also formic acid, and I did not see any different effects, so I thought it unnecessary to do it with the other ones, and it would have also been harder with the cleaning white wine and table vinegar.
Is it reliable to put all these and compare them all on the graph if you only change the concentration of your hydrochloric acid?
Well, I compared them in one graph, but mostly I just compared the bones, the different sizes.
Thank you. And finally, how do you... I mentioned that you could have done a precipitation test or a flame test, but you did not do this. How can you prove that it was actually calcium reaching out to the bones and collagen being left in?
Well, I obviously, with the fluoride, I obviously changed the chemical structure of the bone mineral, which means that it is definitely the bone mineral which is affected.
However, this means that you couldn't actually prove that
A
this
quick
was...
answer, please. Oh, I'm afraid it will take too much time for the quick answer. Thank you very much for the discussion. Thank you.
How long did you measure how long did you measure the elasticity? How long did you keep bone in the acid?
So depending on which experiment, one experiment was for 4 hours, and other ones were for 1 week or for 1 month, depending on which acid I used.
Okay, so you didn't calculate the concentration of the acid in the liquid.
I did not calculate it, but I did look it up online, because I did not find any way to calculate the concentration of the acid.
Was it online said molar concentration or mass volume? Because it is big difference, because for each acid their atoms are different masses.
Molar mass.
Molar mass. So you showed that the colors of the bone changed. Why?
I have a slide to why the colors of the bone change. So they change not because the calcium is white, because it is not. So it changed because there was less mineral, so more light could be absorbed.
Okay. So was the pneumaticity of the bones same, of all the bones?
Well, I measured it at different intervals, but at the end I stopped each experiment when every bone in every acidic liquid got to a full elasticity.
Okay, so next question, where did you hang the weight?
I did not use a weight, I used a force meter.
On which part of the bone did you measure?
Well, I put it in a clamp, and then I pulled it, so it was always about at the ending of the bone.
On the all bones?
Yes.
And how many bones did you measure?
Okay.
36.
Okay. Thank you.
Today I'll be a review on problem 10, elastic bones. The problem text was chicken bones kept in acidic conditions for a few days become elastic. Perform such an experiment in controlled conditions and investigate what components of bones are responsible for their mechanical properties. So the reporter did explain mechanical properties of the bone. She explained the effect of type and size of the bone on the elasticity. She explained bone components, so minerals, proteins, and water. And she mentioned hydroxyapatite and fluoroapatite as main minerals. And she also used same age chicken, so that is parameters which was controlled. But she didn't explain why does mineral hydroxyapatite dissolve. She didn't explain changes of fluoroxyapatite because of the H acid. She didn't mention ratio of acid and water, and she didn't measure concentration, which I think is a very important thing, because she said that pH doesn't affect on the elasticity of the bone, which we don't agree with. She didn't say how many ACEs liquids she used in her research. She didn't even change exactly the acid, and she didn't say temperature, and she didn't explain chemical reactions which appear. So for the opponent, she asked for minerals, temperature, elasticity of the bone, if she measured pH value. She asked for concentration of the acids, And as for types and concentration of the acid, she asked for components of the bonds, and she said that the report didn't link theory and experiment, which I agree with. She asked for not changing the acids and what minerals leached out, so it wasn't told in the presentation. What was responsible for changing the bond? But she didn't mention that each bond is different. She didn't ask for the dependence of acid on the bond elasticity. She didn't ask for acid for the way of concentration installed, and she didn't ask for measuring the force. For the discussion, they discussed changing acid during the experiment, where the reporter said that he thinks that the pH value wouldn't change, and
Okay, we're out of time. Thank you very much for the review. Thank you.